All right, so for these problems, I'm writing all over the screen, but we want to find vertical, horizontal, or oblique asymptotes. So first of all, I'm looking at vertical asymptotes. Remember that a vertical asymptote is an imaginary line that's going to slice through the x-axis. So it has the format of an x equals. So what do we notice here? I see a vertical asymptote slicing through right there, and another vertical asymptote, slicing through right there. So I've got two vertical asymptotes. The one on the left is at x equals -2, and the one on the right is at x equals +2. So the next question is going to ask me, do I have any horizontal asymptotes? Well, do you see anything horizontal slicing through the y-axis? And I do, and that happens at y equals -2. So I end up with 3 asymptotes. The third question is going to ask you, well, hey, what about oblique, slant, or diagonal, which are all the same thing, and we didn't give you any of those. So what is your domain? Your domain is going to be reflected on what you get for your vertical asymptotes. You've got asymptotes at -2 and at +2, which means you cannot have values there. Because remember, vertical asymptotes are untouchable. So your domain is going to go from -infinity all the way to -2. It's going to pick back up at -2, and go to +2. And then it's going to pick back up at 2 and go to +infinity. So this first part right here is everything in this area. The second part is everything, this part, I said blue. This part is everything in this area. And then this part is going to be everything in this area. So again, that is how we're going to do these problems. All right, so let's try another one. I have, please graph the rational function. So this one is slightly different. I have x minus 1 over x plus 3. So x minus 1 over x plus 3. So the first thing I want to do is, because I now have other stuff in the numerator, is I want to figure out where my x-intercepts are. So what I do is I set my equation equal to 0. So we're just going back to x-intercepts. The only way to make a fraction equal 0 is for its numerator to equal 0. So I can ignore the denominator for a second, and I see that I have an x-intercept at +1. So I have an x-intercept at +1, so I'm going to write that up here. I've got an x-intercept at +1. Okay, the next thing I want to look at is, let's look at some y-intercepts. So if I have a y-intercept, my y-intercept is going to be found whenever I substitute in zeros for x's. So I've got a 0 minus 1 over a 0 plus 3, which gives me a -1/3. So I have a y-intercept at -1/3. So I've taken care of x-intercepts, I've taken care of y-intercepts. So now let's look at asymptotes. So where are my asymptotes going to be? My asymptotes, My asymptotes are going to be, first of all, let's take care of vertical. So my vertical asymptote, that means I take my denominator, set it equal to 0, and solve. So I have a vertical asymptote at x equals -3. And then what about horizontal asymptotes? For horizontal asymptotes, I'm going to notice that I've got same over same. So my horizontal asymptote is going to be the ratio of my lead coefficients, which is going to be y equals 1. So as I write all of this down, because we're going to find the graph, and as soon as I x out of here, I'm going to lose everything. So x is -3 and y is 1. Okay. So I have same over same, which is the ratio of the lead coefficients. So now I'm going to look, and the first thing I want to look at is to go ahead and look at my vertical asymptote. So looking at part A I'm going to get rid of, because part A has a vertical asymptote at +3. That's not what I'm looking for. So this one looks like it could be -3, because it's got that imaginary line that's guiding those arms. This one looks like it could be at -3. This one looks like it's at +3. So far I've killed off A and D. So now let's look for a horizontal asymptote at y equals +1. So if I look at +1, well, I've got a line going horizontally, slicing through the y-axis at 1. This one is going horizontally, but it's at -1. So I pretty much narrowed it down to B. So let's look at B for just a second. So if I look at my vertical asymptote is at -3. So I've got this vertical line that the graph is snuggling up next to. I've got a horizontal line at +1. That did not change my color. Okay. And if I need some further validation, I've got an x-intercept at +1. And I've got a y-intercept at a -1/3 right there. So I just verified that it is B. So let's try another one. We have sketch the graph of the function. So what I have so far is we're going to do x-intercepts, y-intercepts, asymptotes. So my x-intercept is going to be found by setting the numerator equal to 0. So I know that my x-intercept is going to occur at 0, 0. So this thing is going through the origin. My y-intercept is going to be found by substituting in zeros for the x's. So I'm going to find my y-intercept. So I get 2 times 0 is 0 over -4 is 0. So again, my y-intercept is also at the origin. So both my intercepts are at the origin. Now hopefully you can zoom in and see this. Option D just got thrown out because that's not going through the origin. So now I'm down to A, B, or C. So at this point, we're going to look at the asymptotes. So for my vertical asymptote, grab your denominator, set it equal to 0, and solve. So I get x minus 4, x plus 1. And when I solve those, that's factored form, I get x equals +4 and x equals -1. So we have asymptotes at +4 and -1, and we're going through the origin. Now the final thing that we're going to look at is going to be our vertical asymptotes. So I've got an x to the first over an x squared. X to the first over an x squared. So if I've got an x to the first over an x squared, that means I've got a small over a big. So I stop my world and say y equals 0. So now I know a final asymptote to look at. And so coming back out of here, I'm going to look at asymptotes real quick first. So I've got them at +4 and -1. I already ignored D because he's not going through the origin. Okay, so let's look at C. Do I have an asymptote at +4? No, I do not. Okay, that looks more like at 1. And that looks like -4. So these ones are flipped. Okay, so let's look at this one. It looks like I've got an asymptote at +4. It looks like I've got an asymptote at -1. So far I'm okay. Now I need a horizontal asymptote at 0. So remember that these are touchable. So coming out this way, it's snugging underneath. Going out this way, it's hovering just above. And this one just kind of sort of slides through, which is okay. For horizontal asymptotes, you can touch them. So far, I'm good with this one. Now let's look at this one. Okay, so I've already killed off C and D. Now let's look at B as a possibility. Let's look at A. So I've got an asymptote at -1. I've got an asymptote at +4. It's going through the origin. And it looks like I've got a horizontal asymptote at 0 that's guiding the graph as I get further away from the origin. So here's where a test point's going to come in. So if I grab a number, look at your scale. This is a 0. Here's 4. Here's 5, 6, 7, 8. If I grab a number between 0 and 4, it should give me a positive y value. If I grab a number between 0 and 4, and this is my answer, then it should give me a positive y value. So I'm going to just shove in a 1. Okay, so I'm shoving in this value. If that gives me a positive y, this is my graph. If it gives me a negative y, then b is my graph. Okay? So now I have a 2 times a 1. I could have grabbed 1, 2, or 3, or any fraction in between. And then I've got a 1 squared minus 3 times 1 minus 4. So that gives me a 2 over, sorry, you can't see that, 2 over 1 minus 3 minus 4, which is going to be a 2 over a negative 6. So this is a negative y value. This is a negative y value. If it's option A, it's got to be a positive y value. So let's look back at option B. And it says if I am right in here where x is 1, I should get a negative value. So you have option B is your answer. Okay, so let's rip through a couple more. I'm trying to get this in one video. It may be a long one, but we'll get it done. All right, so sketch the graph of the rational function. So what I have is full screen. First of all, it's already in factor form, which makes my life easier. So if I want to find x-intercepts, I look at my numerator and set it equal to 0. So I've got x plus 5, x minus 3, and that equals 0. So my solutions would be negative 5 at 0 and positive 3 at 0. So those are two x-intercepts. Now let's do our y-intercepts. Our y-intercepts mean we're going to sub in zeros for all the x's. Sub in zeros for all the x's. So 0 plus 2 and 0 minus 4. So if I shove in a 0 for x, I get 5 times negative 3 over 2 times negative 4. So I get a negative 15 over a negative 8, which is 15/8, which is just shy of 2. Okay, so that's what I know so far. I have this one for my x-intercepts, and I've got this one for my y-intercepts. So now let's go find asymptotes. If I am looking for asymptotes, for vertical asymptotes, I'm going to take my denominator, set it equal to 0, and solve. So what I have then is take my denominator, let's change the color, set it equal to 0, and solve. So again, you're restricting your domain and you're telling me where there's asymptotes. It's the same result for the most part. Okay, so for this one, I'm going to have a vertical asymptote at x equals negative 2 and at x equals positive 4. Okay, x equals negative 2, x equals positive 4. And then finally, what I have is, what about a horizontal asymptote? So for a horizontal asymptote, what I'm going to look for is my degree on top and my degree on bottom. So the top, if I multiply it out, is going to give me an x squared and a whole bunch of stuff. And the bottom is going to give me an x squared and a whole bunch of stuff. And so I have same over same, which means I will have a horizontal asymptote at y equals 1 over 1, which is the ratio of my lead coefficients. So now looking at this, let's see if we can knock something out. I know I've got an x-intercept, or where it crosses the x-axis at negative 5. And I am looking, I think we're just going to have to write this down, and let me zoom in. So I've got a negative 5, 0, and a 3, 0 for x-intercepts. I've got a 0 and a 15/8 for a y-intercept. I've got vertical asymptotes at negative 2 and 4, and a horizontal asymptote at 3. So when I zoom into this thing, let's just see what we got. This one says I've got vertical asymptotes at negative 2 and 4. So here is negative 2, and here is 4. And I'm supposed to have a horizontal asymptote at y equals 1. This horizontal asymptote is at y equals 0. So we just knocked him out. Okay? So let's keep going. I am looking for vertical asymptotes at negative 2 and at 4. Okay, I'm looking for a horizontal asymptote at y equals 1, and this is y equals 0. So look and see what it's hovering on either side of. This is above the axis, and this is below the axis, so it's y equals 0. So let's look at this one. I've got a vertical asymptote at negative 2. I got a vertical asymptote at 4. I've got a horizontal asymptote. This one is just below the 1, and this one is just above the 1, so that satisfies my horizontal asymptote. Getting excited. And so now what are my x-intercepts? I should have one at -5. I should have one at 3. And then I should have a y-intercept at 15/8, which is just shy of 2. So all of those are met. So let's just check and make sure that this doesn't throw us for a loop. I've got one at -2. I've got one at 4. But this one, my horizontal asymptote, is at -1. So that is not my option. All right. So this might be a good place. No, let's do this again. All right. So what I'm looking for is, if I look at this, I've got an asymptote at x equals 0. And I've got an asymptote at x equals 6. So an asymptote at x equals 0 and at x equals 6 means that my denominator must have an x equals 0 and an x equals 6. So if that's the case, only one of those matches that, and that is this one. Okay. Also notice that you've got a small over a big, because you would have an x to the first over an x squared, which means you stop the world and say y equals 0. Okay, so all of those are matching up. And so, hang on, I forgot how to X out. I'm going to come back and do the last two on a separate video because they're a little bit more complicated.